Okay, so this is an introduction to Hess's law calculations. We are specifically looking at finding heat of formations from heat of combustion data using your Hess's law diagram. Now, the question here is simplified for you because you're only at the beginning of your journey. But it really is important that you understand the definition for heat of formation and similarly that for heat of combustion so that you can draw your Hess's law diagrams. So we follow our instructions and it says write the heat of formation for a given compound, and this is going to be what we're calling the top line. So we are going with methane, and heat of formation is the heat change when 1 mole of a substance, so in this case methane, is formed from its elements in their standard states. So you need to be aware that the carbon in CH4 is what it looks like in its standard state, so it's just C by itself, and hydrogen exists as H2, and to balance this I needed to have two H2s. You don't need to write in your standard state symbols. They're not necessary. I'm just going to do it for you for now so that you can see what they are. So this is our top line. It gets the delta H. It's the thing we're trying to figure out. So we've done this part. Number 2, it says write balanced products of combustion for biggest compound in your top line as your bottom line. So CH4 is our biggest compound. It's a heat of combustion, so we would do a down arrow, and if you want to just write it over on the side for yourself. So my mnemonic is FOCDW, fuel plus oxygen gives you carbon dioxide and water. So I know I have oxygen, I know I have carbon dioxide, and I know I have water, and now I balance. So I look at my C's. I have one C, I have one C. I have H4 here, I only have H2 here, so it is necessary for me to put, it is necessary for me to put a 2 here. And then I look at my oxygens, so on this right hand side I have 2O here plus 2O here, so I must have 2O2 here. So if we go back to our point number 2 here, it says write the balanced products. So the balanced products for this are CO2 plus 2H2O. Now, if I look at my equation here, and I know it was done here already, but you will see for point number 3, label my joining down arrow with its delta H and its number. So the number is the fact that there's only one CH4 in my equation. So I'm just going to go 1 by minus 879. I then look at the other components in the equation and label their down arrows with their delta HCs, their enthalpy of combustion value, and their number. So I have only one carbon here, so that must mean that it's going to be 1 by minus 393 kilojoules per mole. And when I look here at my H2s, you will see from this equation here there's only one H2 in the equation, but I have 2 in my top line, so I must multiply 2 by minus 286. Now, to draw our Hess's law formula, I need to look at the directions that my arrows are going. So you will notice that here and here, these arrows are both going in the same direction, whereas over here, these two arrows are coming down. So you just need to kind of be aware of that when you're starting to write. So I'm going to go look at the blue part. So it's delta H plus bracket 1 by minus 879, and that's going to be equal to my other two arrows, which are 1 by minus 393 plus 2 by minus 286. Bracket them up. Now, we want to solve for delta H by itself, and just to make sure you're getting your signs right, normally I would say don't solve anything until you're at the end and you're just plugging it all into your calculator. But just to make sure you're getting the sign right, because you're going to want to move this to this other side, I would solve that bracket. So 1 by minus 879 plus by a minus is a minus. So it becomes minus 879. And again, we just repeat this. And if I now wish to get this 879 to the other side, I have to add 879 to both sides. And when I've done that, I am just going to solve it, put it into my calculator as it is, brackets and everything. And when I have done that, I should end up with minus 86 kilojoules per mole. And this is my final answer. Okay, so if we just have a look again, look at other components in equation for point 4 and label their down arrows with their enthalpy value and the number of components that are there. Use the direction arrows to write Hess's law, so that was blue against green. Just to show you here, so this was the blue side and this was the green side. And then we rearranged it all so that it would match, with leaving delta H on one side. And that is how you do Hess's law, finding heats of formation from heats of combustion.